Hello and welcome to the Arc Woman podcast. This is an exploration of womankind. Here we discuss what it is to be a woman in the modern world while utilizing ancient and modern modalities in tandem to create a bounty of health for the body, mind and spirit. Hello everyone and welcome back to the Arc Woman podcast and welcome to this conversation on cholesterol. This is an episode that literally no one fucking asked for, but I think it's really important for us to understand this amazing molecule and rethink it. I was in the vegan community for 7 years, and man, was I duped. I thought cholesterol was the goddamn devil. And it's not. It's an amazing molecule. It's used in every single element of our body. And it's really important for hormonal health, right? It's super misunderstood. And I just think it's just such a beautiful molecule. So let's talk about it. So what is cholesterol? So cholesterol is a fat-like substance transported through the body via the bloodstream. It moves around with the help of lipoproteins, which basically means fat protein. So lipid is fat, right? So these lipoproteins, they carry cholesterol to different cells throughout the body, ensuring it reaches the places where it's needed. And an interesting fact about cholesterol is that it is in all mammals and it's found in every single cell. Every single one of the trillions of cells that you have in your body has cholesterol. And if we don't have enough cholesterol in our diet to produce, or we don't produce enough on our own, our cells actually have enzymes that can make that cholesterol. So this shows just how important cholesterol is for our bodies, right? It's also essential for our cells to have a built-in way to produce it if necessary. So in science, when we find a cell that has high amounts of cholesterol, it has low amounts of enzyme that can make it. Makes sense, right? But if we find a cell in the body that has low cholesterol, it has high amounts of enzymes, which are basically these proteins that do the work of the body and the cells to make cholesterol. And that just shows us how necessary it is. So why is it so essential? Let's go through a few of the different ways our body uses cholesterol, just so you can understand how integral it is to a healthy body. So number one is cell membrane structure. So cholesterol is a key component of cell membranes, surrounding and protecting cells while ensuring fluidity and stability. It plays a crucial role in membrane permeability, which controls what enters and exits the cells. And by packing phospholipids, also made of cholesterol, closely together, it can reduce the passage of certain molecules supporting the integrity of the cell. So think about it. Think about your skin. That's your outer membrane to the world. Every single one of the cells in your body also has a membrane. And the main component of your membrane is cholesterol. You cannot have a good, healthy membrane that's permeable, that allows good things in and bad things out, and keeps what it needs in and keeps what it doesn't need out of the cell, which is different for every cell in your body. And it keeps it fluid, right? So we have to think about our body. It's not this rigid thing. Our cells are not rigid. They have this fluid, hypermobile, depends on the cell, but generally your cells will have this kind of fluid structure membrane, so it can pack up tightly next to everything else in the body, and so it can be fluid. The other important reason why we need cholesterol in the body is for myelin and nerve health. So cholesterol is essential for forming myelin. Myelin is the protective sheath that surrounds nerve fibers, and it's critical for brain, nerve, and spine health as it insulates nerve fibers and enables efficient signal transmission. So when we don't have adequate cholesterol, the integrity of these protective layers as well as nerve and brain function can be compromised. And so very often, when we see neurodegenerative disorders like Alzheimer's, Parkinson's, and even dementia, we see low amounts of myelin surrounding the nerve cells. So the difference between a myelinated and a non-myelinated nerve cell and how quickly it transmits electrical impulses is pretty significant. There's like 100-fold increase. So a nerve cell that has myelin around it, so it's insulated and it can carry out its electrical impulses and tell different parts of your body what's going on. Say you step on a nail, and the nerve that picks up that you've stepped on a nail is covered in myelin, is covered in this cholesterol, then it's going to be able to transmit an electrical impulse to your brain at a rate of 185 meters a second, which is incredibly fast. Say you stepped on the same nail, but a different nerve picked it up and it was non-myelinated, so it didn't have a coating of fat of cholesterol around it, it's going to transmit that nerve impulse much slower at around 18 meters a second, right? And so you might not think that's really important, but you have to remember that whenever we have neurodegenerative diseases with that we can associate with kind of like low cholesterol production and absorption in the body, Alzheimer's, dementia, and Parkinson's, it's really important for long-term health to make sure that we have healthy amounts of cholesterol circulating throughout the body and being stored properly in the body, because we need to prevent these disorders from occurring. We've all heard of lion's mane. Lion's mane kind of activates these myelin sheath creating cells that live in our nervous system, live close to our central nervous system, and basically make this fatty coating and coat the nerve fibers. And so that's why our brain health gets better when we have lion's mane. That's one of the reasons why when we have this, mushroom in our diets, or we're taking it in a tincture, it's really good for that. But you can take all of that you want. But if you're not getting, a good amount of dietary cholesterol, you're only getting about 10 to 15% of that anyway, but we will talk about that. And if you don't have these supportive pathways in your body to produce cholesterol, say the liver, then you're not actually going to be doing anything good for your body at all. You're kind of wasting your money because you're stimulating these cells, but they don't have the ingredients to actually make the fatty coating, which is based out of cholesterol. So another really important reason we need cholesterol in the body is hormone and vitamin D production. So cholesterol is a precursor for synthesizing many hormones, one of them including vitamin D, which is a vitamin, yes, but it also acts as a hormone somewhat in the body. So without enough cholesterol, the body cannot efficiently produce vitamin D and absorb vitamin D, which is vital for bone health, immune support, and mood regulation. The list could go on. Vitamin D is one of the most important nutrients that women need to be taking. I suggest taking 5,000 IUs a day, which is way above the RDI, but there's a lot of research to suggest that it's completely safe. You can get that from cod liver oil. You can get it from mushrooms as well. You can get it just from fatty fish or basically any animal food, which is also going to have cholesterol. And doesn't that make sense that the vitamin D and the cholesterol come together, because the cholesterol can help the vitamin D absorb? It's also really important for bile acid synthesis and digestion. So cholesterol is converted into bile acids in the liver, which are essential for digestion. Bile acts as a detergent, which kind of emulsifies and breaks down fats that we have taken in through dietary sources, and it allows the absorption of fat-soluble vitamins, which are vitamin A, D, E, and K, and certain minerals like copper to absorb into the digestive tract. So when we don't have enough cholesterol, we can have inadequate bile production, which will cause nutrient deficiencies from poor fat absorption. And it also means we're not absorbing that fat. So say you're eating all this amazing, chia pudding, but you don't have enough cholesterol in your body that is being produced or from dietary sources, you can't actually access that amazing omega-3s. You can't access the vitamin D, E, A, and K. So super important again. And as we're talking about bile, we can't talk about how important it is for estrogen metabolism and digestion, because cholesterol-derived bile also plays a role in detoxification of estrogen and other toxins. So if bile flow or production is impaired, it can hinder the elimination of estrogen and other substances, potentially leading to hormone imbalances and toxin buildup as well. And just to back up and explain this to you, so estrogen metabolism takes place in a few different places in the body, and I'm just going to go through it very quickly here so you understand what I'm talking about. So estrogen travels throughout the blood system, and it's picked up from the liver. And so when progesterone is around, which says, hey, we've ovulated, we don't need estrogen around at this level anymore, the liver goes, okay, first step, I'm going to clean up estrogen from the blood system. Cool. Then I'm going to use an enzyme to break it apart, and then I'm going to store it in bile in the gallbladder. And then that's going to go through the digestive system, and we're actually going to poo it out. And in some cases, 2 different metabolites of estrogen metabolism actually comes out through our urine, so we pee it out. But this one metabolite, specifically the 16 type metabolite of estrogen, is kind of the naughty one that goes through bile salts. So if we don't have enough cholesterol around, we won't be able to digest estrogen effectively, which means that it'll be reabsorbed into the blood system, and this is where we can get really nasty estrogen dominant symptoms as well. I know I'm moving into the direction of talking about hormones, but before we go there, I'd just like to talk about the types of cholesterol and this whole bad, good cholesterol nonsense, and just kind of shedding some light on it so you understand what those terms mean, what we actually mean when we're talking about HDL and LDL. So let's talk about it. So HDL and LDL. So cholesterol molecules are divided based on size and function, which is the two types: HDL, high density lipoprotein, and LDL, low density lipoprotein. So LDL cholesterol, LDL contains larger cholesterol molecules and makes up most of the cholesterol in the body. It transports fats through the blood system to various tissues, stores fats for cell wall repair, and carries fats into cells. And it just generally serves as a key precursor to steroid hormones. LDL particles are larger and they're less dense than LDL particles. And LDL is often referred to as bad cholesterol because high levels can often lead to plaque buildup in arteries. We'll talk about how that's a bit of a misconception, which increases the risk of heart disease. Again, not necessarily true. It transports cholesterol and triglycerides to cells, and it's involved with various metabolic processes, including hormone production, right? So LDL is kind of the baseline of our steroid hormones, and so is HDL to a certain degree as well. When we're talking about LDL and HDL, we're talking about basically this spherical protein that carries cholesterol around the body, because cholesterol isn't just freely floating throughout the body. I mean, to some degree, cholesterol can, but for the most part, it's being carried in a protein, so these lipoproteins. So LDL is a low-density lipoprotein, but it is larger because it carries larger larger cholesterol molecules, but because it can't carry as many, it's low in density. So that's why it's called low-density lipoprotein. HDL cholesterol consists of smaller cholesterol molecules and specialized proteins, so the lipoprotein, that collects excess fats from tissues and returns it to the liver for recycling or removal. So HDL helps maintain LDL levels, ensuring hormones are produced in proper quantities. So this is where I'd like to get into the whole there is no good or bad cholesterol, because we often hear LDL bad, HDL good. And I'd just like to talk about how, the ratio needs to we need more science around this, because there's lots of conflicting research around this topic. As I've said previously, every single cell in the body synthesizes cholesterol because it's essential. However, not all cells can produce enough cholesterol to meet their needs. So the body must transport cholesterol between cells. The liver, for example, produces and exports huge amounts of cholesterol. So its net export of cholesterol is larger than what it takes in. So it's producing a large amount of cholesterol for the body, go the liver. So this provides other organs with the cholesterol they cannot make themselves. And so this is where we get into the nitty-gritty of the circulatory system and cholesterol transport. So cholesterol is transported throughout the body in the circulatory system, but it's a lipid, it's a fat. And so our blood, which is water-based, these two do not mix together. So similar to how if you put olive oil in water, it repels it and they stay separate. And so hydrophobic and hydrophilic. So hydrophilic is water liking, hydrophobic is water hating. And water, will be repelled from water. Lipids are hydrophobic, so they repel water. So this means that cholesterol requires a unique transport system in the body, which is LDL and HDL. So to move cholesterol throughout the body and in the bloodstream, it is encapsulated within these lipoproteins. They are spherical molecules with a lipid layer on the inside which binds to the cholesterol, like attracts like, and a protein layer on the outside that allows it to travel in the blood because protein is hydrophilic. It likes water. Lipoproteins vary in density, with HDL having high density of cholesterol and LDL having lower density, as I said before. So while higher levels of HDL are often associated with better metabolic health and higher LDL is often associated with poorer health, the actual ratio of HDL and LDL doesn't necessarily predict individual health. It's a lot more complicated than that. And this is because the functionality of the lipoproteins, rather than just their density, is what actually impacts health. And so we can see this because any attempts to artificially increase HDL in relation to LDL, so say, and I'm doing air quotation marks as I'm saying this, any attempts from, medication to increase HDL, the air quotation good cholesterol, and lower LDL, the bad cholesterol, has been shown to have no improvement in health outcomes. Let me say that again. Medication that increases good cholesterol and decreases bad cholesterol has no or little improvement in health outcomes. So this suggests that cholesterol levels alone cannot be directly correlated with health, underscoring the importance of lipoprotein function over their quantity and quality. Let's talk about cholesterol production and absorption. So roughly 80% of our body's cholesterol is produced in the liver, while about 20% comes from our diet, mainly from animal foods. So you can't find cholesterol in plant-based foods. It's only found in animal foods. And the reason why? Because all animals have cholesterol. So additionally, each cell can synthesize its own cholesterol if needed. So our body can produce adequate cholesterol internally without relying solely on dietary intake. And dietary recommendations and cholesterol levels is going to tie into this really nicely. So when someone has elevated cholesterol levels, they're often advised to reduce animal foods or dietary fat. However, this approach doesn't address the fact that the majority of cholesterol found in the body is self-produced. So cutting cholesterol intake is not actually going to effectively lower levels of cholesterol, as elevated cholesterol often points to an underlying physiological imbalance that actually needs addressing, not just addressing a quick fix diet change. I find that quite lazy, really, when we talk about how intricate the cholesterol system is in the body and how integral it is to every single cell. If it's high or if it's low, what is that actually saying about the physiological state of the body? Cholesterol is stored different places in the body. So cholesterol is connected and concentrated in tissues that require it the most. So the adrenal glands, which contain the highest amount of cholesterol concentration due to their role in producing steroid hormones. The brain and the spinal cord come in at number 2 with about a quarter of the body's cholesterol. And so this reflects on cholesterol's importance for nerve health, for that myelin sheath coating that we were speaking about before. Cholesterol is also found in bone marrow and it circulates in the blood, of course. When there's an excess in the bloodstream, the liver converts that cholesterol into bile salts for excretion. And if that gets into the digestive tract and the body goes, hey, we need more cholesterol, it'll reactivate it and kind of take off it like a long molecule chain that the GI tract can attach to it and reabsorb it so we can use that cholesterol again. We have this cholesterol, digestive cycle. So we're always using cholesterol. It's, cholesterol cycling throughout our body and we're reusing it all the time. You might find this very interesting about the absorption of dietary cholesterol. So most of the cholesterol we consume is esterified, which means that our gut cells attach a long chain of molecules to it, which makes it unable to pass through the gut lining for absorption. So I was talking about how, the cell membrane. So it'll have channels for cholesterol to move through. And if cholesterol doesn't have this long molecule chain to it, hasn't been esterified, it'll move through that gut lining really quickly, really easily, and it'll go into the blood system, it'll be reactivated, and it can be used again. But if it's esterified, it has this long chain molecule to it, it's literally too big. It physically cannot pass through this channel. So this is how our gut plays a really important role in modulating and controlling, our cholesterol levels. So the body requires additional cholesterol every now and then, right? So it can de-esterify about 10 to 15% of the dietary cholesterol that we need, which is a really small portion compared to the total body cholesterol, but it is, 10 to 15% of the cholesterol that you're eating. So say if you have low cholesterol and your body can't reuse the cholesterol that is in the body, that's really great that the gut can de-esterify this cholesterol so we can reabsorb it and we can use it. So it doesn't have a huge impact on total cholesterol in the body. It's such a small amount, but there is still an impact there. So we're about 20 minutes in and I haven't brought up the whole cholesterol, heart disease, cholesterol, cardiovascular disease, heart attack, arterial wall situation. Okay, so let's talk about cholesterol fear and let's try and get a bit of a shift in understanding. Because cholesterol has historically been believed to accumulate in the arterial walls, causing heart disease, right? If you have high cholesterol, your doctor is going to tell you have to go on statins to lower it because you're going to get heart disease. However, it's now known that cholesterol buildup in the arteries can only occur when inflammation is present. So cholesterol itself is never and has never been the root issue. Rather, it's a level of inflammation in the body that triggers cholesterol buildups. And we can see this in the data. So numerous studies reveal cases of individuals with high cholesterol levels that don't have any risk of heart disease, and alongside others with low or normal cholesterol levels who have had developed heart disease and cardiovascular disease. So there's common thinking and like this factor linking cholesterol buildup and cardiovascular disease issues is inflammation. It's not cortisol and it's not cholesterol, sorry. In other words, inflammation is the underlying cause driving cholesterol to accumulate in the arteries, not cholesterol itself. We've got some beautiful foundational understanding of cholesterol under our belt now. So let's move on and start talking about reproductive hormones and cholesterol. So cholesterol is essential for producing steroid hormones, which include every single one of our sex hormones: estrogen, progesterone, testosterone, and stress hormones like cortisol. So cholesterol is transported into the cells where it enters the mitochondria, and the mitochondria transport proteins and guide cholesterol to be converted into pregnenolone, the parent hormone that can produce all other reproductive hormones. So we cannot produce estrogen, progesterone, luteinizing hormone, follicular stimulating hormone. We cannot produce any of these without cholesterol. It is the backbone of all of our sex hormones. Cholesterol and fatty acids are also really important for reproductive function in the ovaries, uterus, and placenta. So when we have abnormal lipoprotein metabolism, it's being linked to infertility and dysfunctional oocytes, which are basically our unmatured ovums. So they don't mature the way we'd like to see them. They don't mature quickly enough, or maybe they're maturing a little bit too slowly, or, they're mutated. So we usually will see if a cell as well, if a fertilized embryo has low amounts of cholesterol, it'll just initiate cell death. So if we don't have cholesterol in that body, in that new forming fetus, it will self-destruct basically because it doesn't have that essential key of life, which is cholesterol. Another really interesting fact that I found is that researchers found that women's cholesterol levels fluctuate with monthly changes in estrogen. This natural variation suggests that cholesterol measures should be considered by the menstrual cycle phases. So studies have shown that women's total cholesterol can vary by as much as 19% over the course of her hormonal cycle, which could influence medical recommendations regarding cholesterol. So say if you went and had your bloods tested when you're on day 2 of your period and your estrogen is super low, your cholesterol is going to be normal, or it might even be low. But say you went when you were ovulating and your estrogen is high and therefore your cholesterol is going to be high, this could be the difference between a doctor recommending statins to you and not. As estrogen rises, HDL also rises and it peaks around ovulation. Conversely, total cholesterol, LDL, and triglycerides decline as estrogen increases, reaching their lowest points just before menstruation. So this trend indicates that optimal cholesterol levels align with the rise and fall of estrogen. And this makes total sense. This makes absolutely total sense. If cholesterol is the backbone of our sex hormones, our steroid sex hormones, then we need more of it around when we have peaks in hormone production, which is what we have during ovulation, because we are going to be producing huge amounts of estrogen, of course, to build that endometrial lining in, preparation for possible implantation. It's also really important for producing testosterone. So we have a peak of testosterone around the time that we're ovulating, as well as luteinizing hormones. So it makes sense that our liver is going to be making more and putting more HDL and LDL into the blood system around this part of the cycle, because we need to make more hormones around this part of the cycle. Low total and LDL cholesterol levels can reduce the production of estrogen and progesterone, which can impact menstrual regularity, fertility, and it can even lead to menopause-like symptoms like hot flashes and mood changes. Cholesterol is really crucial for mood-regulating hormones like estrogen as well. So estrogen helps to bind dopamine to the brain. Progesterone likes to bind GABA to the brain. If we have low amounts of cholesterol, therefore we have low amounts of these sex hormones circulating, it also means that our neurotransmitter regulation in the brain is also going to be disrupted. And so this can lead to mood swings, depression, anxiety, especially during hormonal fluctuations in women. Cholesterol is also really important for regulating energy and physical health. So inadequate cholesterol can result in fatigue, muscle weakness, brittle bones in women. So we need estrogen to pack in lots of calcium into bones. So we know from the data that women who have had low circulating estrogen throughout their lifetime will have higher rates of bone fracture later in life. And the reason why is because estrogen packs calcium into the bones, and it's also really important for increasing bone density, and muscle density. So Testosterone and estrogen, we need a certain amount of them around to produce bone, mineral density, and muscle mass, right? If we have low cholesterol, it means that we're going to have low muscle mass and low bone density, which means later in life when we don't have any estrogen around and, in that early part of our life where we're supposed to be building strong muscles and, building really dense bones, we're more prone to if we fall over and we break our hip, you know what I mean? So you might not be thinking about these things now, but for long-term health, it's really important to think about how am I regulating cortisol? How am I supporting sex hormone regulation in the body? How am I supporting my body now so my life later in life is actually going to be more prosperous? I'm going to be healthier. I'm going to have good bone and muscle density as well. And this also plays a part in vitamin D. So vitamin D is really important for bone mineral density specifically. It does play a part in some muscle mass to a certain degree. But again, we can't have any vitamin D being absorbed into the body if we don't have any cholesterol, because cholesterol makes up those bile salts. So you can see it's really hard for me to talk about things in isolation because nothing's in isolation, especially with a molecule like cholesterol. I've spoken about how cholesterol can impact cycling women, but I'm aware that there are probably women listening to this who are on hormonal birth control, and we do have some stats, we have some information on how cholesterol and hormonal birth control can have some impact on women's health. Hormonal birth control, particularly oral contraceptives, are associated with increased LDL, which is that low density lipoprotein, cholesterol, total cholesterol, and triglycerides. Studies show that it can also raise insulin levels and increase markers of inflammation such as CRP. Some forms of hormonal birth control are have favorable impacts on cholesterol profiles, specifically progesterone-only formulas and combination pills with DESA. We found that these do have the best cholesterol profiles in meta-analysis of 9 different oral contraceptives, but that kind of goes back to what I was saying before about how we can't just look at the lipid profiles, we need to be looking at everything else in the system. So we know that hormonal birth control increases oxidative stress, CRP, which are both markers of inflammation in the body. And it can also increase insulin, which is also going to, down the line, going to be increasing cortisol in the body as well, which again is going to increase inflammation. So this inflammation is what's going to cause cholesterol to become problematic, right? And so I think it's really interesting that we're seeing that it's bettering profiles of cholesterol over a long-term period of time with hormonal birth control pills. But I'd just like to see what that long-term health is going to look like for these women who have been on hormonal birth control. And we're seeing, quote-unquote, better cholesterol lipid profiles in blood work. As I was saying previously, cholesterol levels fluctuate in response to the body's hormonal shifts, specifically estrogen levels that typically help optimize HDL levels, while progesterone supports balanced total cholesterol and triglycerides. With hormonal birth control, these natural hormone-driven cholesterol patterns are disrupted as synthetic hormones like the pill or any other type of hormonal birth control that you're on. They prevent ovulation and thus they suppress natural hormone levels. So this can lead to persistently low estrogen and low progesterone, right? Which can negatively impact cholesterol, triglycerides, and blood sugar profiles as well. Which means that it could possibly impact cholesterol digestion, reabsorption, and its functions in the body. We touched on reproductive hormones and their interactions with cholesterol, but one of the most important endocrine systems and its impact on cholesterol is the thyroid gland. So the thyroid gland plays probably one of the most significant roles in managing cholesterol levels through its hormones, T3 and T4 and TSH. So thyroid hormones, specifically T3, are crucial in regulating LDL receptors, which help to clear cholesterol from the blood. So we have T3 around in the blood, it's being released from the thyroid, it's going to a cell and saying, hey, there's LDL around, open up that channel and let this cholesterol in. So it regulates the amount of LDL we have in the blood system, right? Thyroid hormones that activate LDL receptors that promote the clearance of excess cholesterol, while T3 specifically protects the LDL cholesterol from oxidative stress and free radicals. So it's protective of LDL, which again speaks to how important cholesterol is in the body. If we have the thyroid hormone protecting it and allowing it to enter cells. But if we have inadequate levels of T3, this allows LDL cholesterol to oxidize in the blood system, and this can lead to inflammation, which is a key factor in when we talk about heart disease and atherosclerosis, and when we talk about things like, cardiovascular disease and cholesterol. Is this person doing a thyroid panel? Are we looking at their T3, T4, and TSH? There's a lot more to this system than just going, you have high cholesterol, this means that you're going to have heart disease. Not necessarily. You could have high cholesterol and you could also have high T3, which means that you're actually able to get it into the body cells. So if we have too little T3, it means that LDL can stay in the blood system for too long, and it can oxidize and it can cause inflammation, which makes that cholesterol a little bit more dangerous to have in the system because, that could lead on to possibly cause things like heart disease and cardiovascular disease. But what about when we're producing too much? So hyperthyroidism, as opposed to hypothyroidism, can lead to low cholesterol levels due to excessive T3. So this causes overactive LDL receptor functions and excessive cholesterol clearance. So the opposite of having low T3 is high T3, which means that it's kind of like, okay, everyone, open up your LDL channels. We're going to allow all of this LDL to empty. So this leads to low LDL. So we don't want low LDL or high LDL. We want balanced and regulated and, this homeostasis of LDL in the system. It's there when we need it, it's cleared when we don't, right? And the thyroid plays a really important role in regulating this. But if we have hyperthyroidism, producing too much T3, or hypothyroidism, we're producing too little T3, this can impact our cholesterol lipid profiles. Going on from this, we can talk about cholesterol and blood sugar regulation. So our ability to manage blood sugar levels directly impacts insulin sensitivity. So insulin significantly reduces thyroid hormone levels, while thyroid hormones also impact insulin functions at the fat cells. So this relationship affects the LDL receptor activity and cholesterol uptake in the liver. When we have imbalances, particularly in insulin resistance, so our cells are resistant to insulin, this can disrupt this process. Insulin sensitivity plays a crucial role in regulating cholesterol metabolism, even more so than obesity. So research has shown that disruptions in cholesterol metabolism can occur in individuals regardless of their weight. So in cases of insulin resistance and type 2 diabetes, cholesterol synthesis is upregulated while absorption is downregulated. Studies have also indicated that there's a strong link between insulin resistance in women with PCOS and elevated cholesterol and triglyceride levels. Research has also shown us that there's a really strong link between insulin resistance in women with PCOS and elevated cholesterol and triglyceride levels, and this is the mechanism that we're talking about. Because women with PCOS often exhibit higher amounts of triglyceride and LDL cholesterol levels, with averages at around 26 milligrams per deciliter and 12 milligrams per deciliter higher. Generally. So it's 26 to 12 milligrams per deciliter higher than women who don't have PCOS. In contrast, HDL cholesterol levels are around 6 milligrams per deciliter lower in women with PCOS. So this highlights the common trend in blood sugar dysregulation and how this ties in insulin sensitivity, our thyroid hormone as well. So approximately 25% of women with PCOS also experience thyroid dysfunction. So we kind of have an underactive or hypothyroidism. So we're not producing enough T3 and T4 in its active form. So if you have PCOS and you also have high cholesterol levels, you might want to go and have your thyroid panel done. So go and have T3, T4, anti-TPO, and you also want to be looking at your free T3 and T4 as well. I did say earlier that the gut can esterify or de-esterify cholesterol. So the gut plays a really important role in cholesterol absorption and activation in this GI tract. There's also some really interesting research that indicates that pathogens like H. pylori, which primarily reside in the stomach, can raise cholesterol levels by disrupting stomach acid production. Conversely, autoimmune conditions that can lead to low cholesterol levels as well. So since much of our immune system is located in the gut, so around 80% of our immune system resides in the gut, addressing gut health can become really essential for individuals with autoimmune diseases and also, any autoimmune issues, leaky gut,
kind of all under the same umbrella. Gut health is going to be really important for you, especially if your metabolism of cholesterol or your cholesterol levels don't look optimal. The metabolism of cholesterol by gut microbes might also significantly increase both intestinal and blood serum cholesterol concentrations, which can directly affect overall health, right? Emerging studies also show us that certain types of gut bacteria can balance these microbial communities and also contribute to cholesterol levels too. Gut health isn't going to be the root cause of cholesterol issues for everyone. I'm just saying this because I think it's a relevant factor, because we have these gut microbes that can turn off and on different genes in the gut microbiome that can, de-esterify or esterify cholesterol, which would impact our digestion of cholesterol and whether we're reuptaking it and using it effectively. I'm also bringing this up because 80% of our immune system lives in the gut. And when we're talking about inflammation, we're talking about the gut, basically. Almost always we're going to be talking about inflammation in the gut when we're talking about some type of cholesterol dysregulation as well. So if you have any gut problems and your cholesterol is also dysregulated and you don't have good and optimized cholesterol levels, then focusing on gut health is probably not going to be a bad idea for you. So you're probably thinking by now, okay, what is cholesterol levels supposed to look like, right? So optimal cholesterol, total cholesterol ranges are supposed to be between 170 to 200 milligrams per deciliter. With clinical experience, I would suggest closer to 200. That might be more ideal for women, specifically because we need way more cholesterol around to produce sex hormones. However, it's really crucial to consider your individual health trends rather than fixate on achieving a perfect lab number. Often women become really obsessed with these specific numbers, but if other health markers are progressing well, so you're really healthy, say your CRP, your inflammation markers are really far down, you have good amounts of vitamins in the blood, your everything else is really good, but your cholesterol is sitting at 215 or 220, that might be perfectly acceptable for you. So the factors that contribute to elevated cholesterol can include mineral imbalances, insulin resistance, blood sugar fluctuations, hypothyroidism, hyperthyroidism, gut health issues, and conditions like insulin resistance that are based within PCOS, which also have a baseline in high amounts of cortisol. If you wanted a deeper dive into cholesterol-related blood work, check out the podcast I did with Andy Lucas, where we did an optimal cholesterol levels discussion, and we kind of went through his book Blood Work that he collaborated with another naturopath called Miranda, and it goes through optimal levels. And that book, I would highly recommend buying that if you're a practitioner, or even if you're just interested in doing your blood work over your lifetime, because what we see as optimal and what we see as normal are two very different things. There's a few different reasons why, our blood work isn't optimized, is because we base it off of population statistics and outdated beliefs around molecules like cholesterol. So the reason why we have such an interesting perspective on this molecule starts with a guy called Ansel Keys. Ansel Keys was a scientist and a professor in the 1950s and 60s who really popularized this idea that animal protein was the absolute devil. It was filled with cholesterol, and that was what was killing so many people at the time. Now we have prospective studies and we can actually look at the data, and we know that around the time that we saw more heart disease and cardiovascular disease is around that time that people started to eat more processed carbohydrates. So this was freshly post-war World War II. And so the agricultural industry in America, specifically corn, soy, and wheat, did not want to lose their profits because they were getting such huge subsidies from the American government because they needed to feed more people, right? And it is cheaper to produce large amounts of these crops than to produce animal proteins, which previously, that's what most people were getting all of their protein and fat from. They were getting it from animal sources of protein. So they didn't want to lose their subsidies, so they basically paid a few different scientists, one of them being Ansel Keys, to popularize the idea that cholesterol was a huge problem and it was causing all of this heart disease, which is, the paradox is that the times that he was doing this research on the public was when the public was eating the lowest amount of cholesterol, and he nitpicked. So he did 9 countries and he went to 9 different countries And he chose the countries that showed this correlation between high cholesterol intake and high amounts of heart disease and cardiovascular disease. But he actually left out about 13 to 14 different countries that would have fuddled his results. And the reason why he was fudging his research results is because he wouldn't have gotten kickbacks from the agricultural companies that were making lots of money out of corn, soy, and wheat if he didn't do that. So that's basically why we have this really warped idea around cholesterol. And even in the 1960s, Ansel Keys himself even admitted that dietary cholesterol does not equal serum cholesterol, that we only deesterified around 10 to 15% of our cholesterol, which completely debunks his theories and his whole basis of science, which for the most part has formed most of the vegan perspective around why we need to be avoiding high cholesterol foods. So hopefully this has been enlightening for you and interesting. I think cholesterol is such an amazing molecule. I'm grateful for cholesterol. I'm grateful for bodies that are able to modulate and digest it and use it effectively. If it's too high, it's not good because it can oxidize and it can cause inflammation. If it's too low, then it means our body doesn't have this essential molecule in the body. So when we're thinking about any molecule in the body, we can't think bad or good. We have to think about this symbiotic, intricate relationship our body has with each of these molecules and why it's there. The fact that every single one of our cells in our body produces cholesterol and needs cholesterol really speaks to the fact that it is essential. And when we cut it out of our diets completely, or when we eat diets that are low in cholesterol, so we're not able to kind of, give our body a break and produce some, so it doesn't have to produce such a huge amount of cholesterol all the time, then this is a bit of a problem. And I just think for women as well, not being afraid of cholesterol is really important for hormone production, especially if you are a woman who's wanting to fall pregnant soon. Eating foods that are really rich in cholesterol is going to be great for you. So hopefully this helped you out and maybe dispelled a few myths and understandings around cholesterol. And I will see you next time.